Alright, so today we are looking at how to go through transcription and translation. So I have already written up here our DNA sequence that we're going to be using. So we have our 5 to 3' strand and our 3 to 5. So we're actually going to start by transcribing the 5 to 3' DNA strand. So we are using the 5 to 3 DNA. So transcription is using DNA to make RNA. So if we use this information and we need to transcribe it, we'll be making RNA, but our strands always go in the opposite direction. So since DNA is going in the 5' direction, RNA goes in the 3'. And then we use those base pair rules. So if there's an A on the DNA, that would pair to U on RNA because we don't have any T's. C would pair to G, A pair to U, G would be C, T would be A, another T would be A, and we continue that all the way down, again, using those base pair rules. And then that would be the 5' end of our molecule. Okay, now if we want to translate that, now we're using the RNA to make DNA. Now the thing about translation is it always starts on the 5' end. Okay, so in this example, our 3' end here is at the beginning. So we do not start here and start looking for an AUG sequence, which is our start codon. Instead, we have to go to our 5' end that we see down here, and we need to read it from right to left. So again, always in the 5' direction to the 3'. Also, we do not start at the very beginning of the RNA. We have to find the first start codon, which is AUG. So if we move along this molecule, we come to an AUG. And then we can separate them into codons. So then we have CGC, then UUC. So codons are groups of 3 nucleotides. Then ACG, CUU, UAG, UGA, ACU, and we have 2 left over. We'll come back to that. Then we use that genetic code, and this will always be provided for you on an exam. You don't have to memorize it, and if you Google it, there are lots of different ones. They all say the same thing. They're just set up a little different. But if we look up AUG in the genetic code, that always codes for methionine. So if we're translating it, our amino acid sequence would start with methionine. Then if we look up CGC, that is arginine. And we can abbreviate by the first 3 letters. If we look up UUC, we have phenylalanine. If we look up ACG, that is threonine. If we look up CUU, that is leucine. And then UAG is actually a stop codon. So we stop here. It doesn't matter that there are more nucleotides down through there. We stop translation at the first stop codon. And there are 3 of those that you'll see on the genetic code. So again, we just use the genetic code. We look up each codon. Here you just have to remember you're always going in the 5 to 3' direction. So here you want to look up ACG, not GCA. Okay, so you have to keep yourself going in the 5 to 3' direction. Now, if we were using the 3' DNA strand, then our RNA would be going in the 5' direction. And then we could start on the left and go to the right. So it doesn't matter, again, it's not always right to left or left to right. You have to find that 5' strand before you start translation. Then you find the first AUG sequence and go from there to come up with those codons. And then I want to show you just one more thing, and that's with the mutations. So there are lots of different types of mutations. The one that I'm going to show you is just a base substitution. And what I'm going to do is I'm going to change this thymine here to a guanine. So again, this is a base substitution. Okay, so now if we change this T to a G on our DNA, that would affect our RNA. Let me just get out a different color here. Okay, so then on the RNA for our mutated, instead of this being a U, it's now going to be C, U, C, and then everything else is going to be the same. So this C is the only thing that we changed. But now if you use that genetic code, and if you look up CUC instead of UUC, because we've changed that nucleotide, now if we look at this mutated, what's going to happen? Every amino acid is going to be the same. So methionine is still the same. This codon here is still the same, so that's still arginine. But what's different is instead of having UUC to bring in phenylalanine, CUC is going to bring in leucine. And then all the other nucleotides are unaffected. And so again, that base substitution changes this one amino acid. Everything else is the same. Okay, now if we get a little bit more severe, let's say that now, instead of just changing that nucleotide, this T, now we're going to completely delete it. So if we delete this T on our DNA, we're not doing base substitution, now we're going to do a deletion. This causes what's called a frame shift mutation, because now we're not only affecting just one amino acid, but now what's going to happen, if we look at our deletion, this is all going to be the same, but now, because we've removed this U, because there's not a T there anymore, it's going to change our groups of 3 nucleotides. So we'll still have AUG, but now without this U, we continue on UC, AC, because now we have deleted that one. So now whenever we do our groups of 3, we still have our AUG. We still have arginine there that's the same. But now, whenever we group these into groups of 3, we've changed our codons. So now we have this grouping. And if now if we look up C or UCA, that's going to give us serine. Then CGC gives us arginine. And we're just going to keep going. I'm not going to take the time to go through all of them, but now we would look up these groups. Well, I can tell you what's going to happen here is that now we don't have a stop codon. Okay, so by removing the stop codon that was up here, this protein is going to be much larger than it was supposed to be. Plus, we have all of these different amino acids that are now in our chain. So this has a much more significant impact on the protein that it's producing whenever we insert or delete. And those are called frame shift mutations because they're shifting our groups of 3 and they cause a more significant impact after the deletion. Whereas with a base substitution, we're really only affecting most of the time one amino acid. All right, there will definitely be questions like this on your test. If you still don't understand this, please let me know and we'll go through some more examples.